Welcome to the American Society of Agronomy's webinar series on cover crops. My name is Luther Smith, the Director of Certification and Online Education for ASA, and I'll be your host for today's webinar. I'd like to start off by thanking our sponsors who, with their generous support, have made it possible to bring you this webinar at no charge to our participants. SARE, Sustainable Agricultural Research and Education, Iowa SARE, Minnesota SARE, National Association of Conservation Districts, DuPont Pioneer, Cover Crops Solutions LLC, National Wildlife Federation, Grassland Oregon, La Crosse Seed, the Cisco Companies, American Farmland Trust, Department of Soil Science, University of Wisconsin, Klinkenborg Aerial Spraying and Seeding, and Practical Farmers of Iowa. I'd also like to especially thank Sarah Carlson of Practical Farmers of Iowa and Ryan Stockwell, National Wildlife Federation. Sarah and Ryan's involvement and help with this program has helped make it possible. Our series began last Thursday and we continue today, and just to give you an update on our next two webinars, coming up on March 20th, cover crop seed selection and planting, and March 27th, cover crop management and termination. If you'd like to learn more or to register, go to our website, www.agronomy.org. And even though they are free to you as a participant, you still need to register in advance like you did for today's webinar. A popular topic for additional information on resources, I got ahead of myself on that one, SARE, Sustainable Agricultural Research and Education. We'd like to direct you to their website to learn more about cover crops. The SARE programs provide farmers, researchers, and professionals and graduate student opportunities to conduct research that advances sustainable agricultural practices. To learn more about cover crops following this webinar, check out the Cover Crops topic room on the SARE webpage on your screen. And though we're covering multiple topics related to cover crops these 4 weeks, we are not going to cover crop insurance. There was a webinar that was done on January 23rd that did a good job of covering the relationship cover crops and crop insurance. So if you'd like to learn more about that, please go to that web address that's on the screen right now, and you'll learn more about cover crops and crop insurance. Asking questions for today's webinar, please use the question box to the right or left of your screen in the dashboard that appeared when you connected. Anytime during the webinar, you can write your question in the box, and then the speakers will address them at some point throughout. If we don't get time to address all of them, as last week, if you were on, there were many questions that came in, and we just didn't have enough time to address all of them. You will get a response in the coming weeks as people will field those questions and then respond to them. So let's move to today's topic, combining livestock, manure, and cover crops. Our first speaker will be Tim Harrigan. Dr. Harrigan is an associate professor in the Department of Biosystems and Agricultural Engineering at Michigan State University. The focus of his research, teaching, and extension programs is in developing farming systems that improve soil health, protect water quality, and build sustainable agroecosystems. His recent work has been in reintegrating manure, cover crops, and low-intensity tillage to improve soil quality, protect the environment, and enhance farm profitability. Following Tim will be Kent Solberg, Seven Pines Farm in Minnesota. Kent and his wife Linda own and operate a grass-based livestock farm near Verndale, Minnesota. Kent has a passion for the land and has been involved in planned grazing management, pasture-based livestock, and integrated crop and livestock systems for over 20 years. Excuse me. For the past 5 years, they have been using cover crops and seeded annuals to extend their grazing season and improve soil health. He serves as the livestock and grazing specialist for the Sustainable Farming Association of Minnesota and has taught college-level courses on forages, grazing, and livestock management. So Tim, I'm going to turn it over to you, and you can begin your presentation.
Okay, well, thank you, Luther. I appreciate the nice introduction, and I'd like to thank everyone today for taking time out from their busy schedule. I think I'm ready now. To join us today. It's always a pleasure to talk about cover crops and some of the issues related to soil health. And the topic of my presentation today will be reintegrating livestock manure, cover crops to build soil health. And I chose reintegrating because I think, if we think historically, these issues, manure, cover crops, and low-intensity tillage, these were part of our farming systems historically, and I think many of the changes over the last several years.
Hey, Tim?
Yes?
I think you have to hit show your screen. We're still seeing the title page. Share my screen. Okay. Show your screen.
Okay. Here?
Let me check here. It hasn't opened up to your screen. There it is. Now you're ready. Okay, go ahead.
Okay, sorry about that, everyone. So as farms have become more specialized over time and more extensive use of commercial fertilizers, and this integration that we've had in the past has sort of gone by the wayside. So I think there's some wisdom in it, and I'd like to work on that a little bit in this presentation. I'm going to refer quite often to farming systems because I really think we need to begin thinking about managing soils for soil health as a system-wide opportunity, and not just, for instance, a tillage operation. I think that was quite common back in 10 or 15 years ago. Farmers would often ask me, what tillage tool should I use to alleviate deep compaction? And it was clear to me that that was one part of the solution, but they really needed to be looking at a number of natural processes, freezing and thawing, cover crops rotations, a number of things in order to really initiate and continue the process. So we're really looking at trying to find a balance of these soil chemical, physical, and biological properties. And low disturbance tillage, I think, is critical to that. That can mean a number of things, all the way from no-till to, well, any number of reduced disturbance operations. There's a lot of things we need to do with tillage on the farm, but we need to look for opportunities to reduce the intensity of that. And I think what I've seen, whether we're looking at trying to improve yields with cover crops and manure, whether we're looking at trying ways to accelerate issues with soil health, we see better results with cover crops and manure with the combination. There's synergy there. Compared to either a cover crop or manure alone. So if you have access to livestock, you really have a head start, I think, on this bit of a challenge that we have in building soil health. The key issue, I think, well, one of the key issues is to avoid this over-tillage trap, because tillage, we need it in many ways to prepare a seed bed, incorporate amendments, do a number of things, but it's really a fast way to increase pore space if we've had some problems that we need to address, soil compaction issues, for instance. It improves infiltration, drainage. But the problem is that the tillage-induced pore spaces are not stable. They're not structurally stable, so they're not very resilient. They don't resist recompaction on further trips across the field. So we really need to protect that structure, and it takes a long time to build that. We can destroy it quickly with tillage, but good soil aggregation and soil structure take a long time to build. And we really need to look at these biological processes, root growth, microbial activity, earthworm activity, and such. There's a law. This is a partial list of some of the benefits we see: increased organic matter, holding capacity. We can improve aggregate stability, water infiltration, decrease evaporation, soil bulk density. These are all very positive things that we can expect, but it takes time, and there's a time scale involved, and there's a little bit of a patience involved. Now, when I first started looking at this, I began developing this slurry seeding concept back in probably 2001 or 2, and one of the first questions we began to have as we thought about actually mixing directly seed and manure slurries is salinity going to be an issue? And I'm in Michigan, so we don't have the salinity issues that they do west of Mississippi, for instance, but still, we're looking at the seed micro environment. Certainly, we didn't want to create problems. So what I've got here with this graph is I've got relative crop yield here from 0 to 100% on the vertical axis. And down here we've got EC, measured across a range of what are classified as sensitivities for different crops. So you can see basically as salinity increases, whether it's a sensitive or a tolerant crop, as the salinity of the soil increases, we would expect to see decreases in yield. For instance, what we might see as a moderately sensitive crop would be red clover or orchard grass. Tall fescue and wheat would fall into this moderately tolerant category, and rye and barley might be considered more tolerant. But certainly we had some concerns about this, and I think there's, if you refer to the literature, there's frequent references to issues with salinity with forage and cover crops. So we did a number of things. We did a germination test, and here what we did was we simply soaked the seed in manure for 24 hours, and then we placed the seed in a petri dish and did the germination test. So here on the vertical axis, we've got anywhere from 0 to 100% germination based on the number of seeds that were in the dish. And here we've got our time in hours. And basically, we wanted to capture the rate of germination based on, one, with deionized water as the substance we were soaking it in. And when we were using a dairy slurry here that we planned to do our seeding with, so we did a 1/2 mix of the dairy slurry. Half of that was deionized water, and that's in green. And then we did our full-strength dairy slurry here in our orange. You can see the effect on the cereal rye that we had. We didn't have much of a depression in the cereal rye. Now, this is a fairly tolerant crop, but we did have delayed germination. Not much difference here. We did at least 9 or 10 different forage and cover crops, and we saw a variable response to this. For instance, here, forage turnips, not much impact, more rapid emergence with deionized water. Manure slowed it down some. You can see here at full strength, we did see quite a delay and even a decrease. So we had some concerns. Luckily, I did some work in the field before I did these trials, so I wasn't too discouraged. We also looked at the greenhouse, and we had some plants in pots, and this was forage rape, and we had orchard grass here. Basically, we just wanted to look at manure versus no manure, and on this half here, on both sides, this is where we tried to simulate the action of the airway, the aeration tines, and then basically mixing the seed and slurry and dumping it in there. And this here, that we call a normal seed bed, we just basically either no manure, or where we use manure, we mixed it in the surface like we would if we did a broadcast application and then tilled it. And we could see that where we tried to simulate the airway, we were not fully successful. And we had variable results in contact with manure. So I think if I'd done these tests first, I think I would have been a little more discouraged. Other trials didn't show up quite as well. I likely would have been somewhat discouraged. But fortunately, I did some work in the field first. Now, with slurry seeding, we were simply mixing seed directly in the manure tank. And then we were using the airway. So if you're not familiar with this tool, we had basically the seed is with manure in the tank. It's delivered to this distributor chopper here. We have these aeration tines in front that are loosening and fracturing the soil. Then each of these drop tubes is oriented so that it's directly behind these tines. So the seed-laden slurry is being dropped directly into that loosened and fractured soil. This is a sort of a side view of the soil. I've highlighted the action of the loosened soil by the airway tines here. They're offset. That's why you see differential depth, basically on a horizontal or a vertical plane there. But we run them up to the hub 7 or 8 inches deep, and you can see where I've highlighted the loosened soil, so you can get a sense of what's happening there. But we're not tilling the entire soil profile. We're loosening and fracturing the surface. We're creating a roughened surface with random roughness, so it's really a great tool for keeping residue on the surface, but also, I like to call it, it creates an absorption bed. So that rainfall hits and it absorbs really well. I've got a few videos here. They're just short, 1 or 2 minutes, but I want to show you some of the work we're doing in the field, because I think that'll give you a better sense of both the equipment and also the results. So the first part here is one of our cooperating farms. We're Slurry seeding with swine slurry at 3,000 gallons per acre here, and we've got a couple different cover crops. So we're applying them directly. That's our seeding operation. We also wanted to take a look at some other operations, so we direct drilled the same crops, and then we came behind that and put manure over the top of the drilled crops because we wanted the contact with manure, the access to the nutrients. We weren't quite sure, how to sort out the issue of the seed bed. So this is a random roughness. It's a rough surface, and it doesn't look anything like a seed bed. But if you have patience, really it's quite surprising because we get great cover crops. Uniform across the field. This was drilled first and then slurry applied. But oilseed radish loves manure, it loves the nutrients, and this is drilled with no manure. You can see that it's quite scavenging and it's looking for nutrients, and we're not a lot there. Now we have some options here that some folks don't have. We have wheat in a lot of our rotations, and that provides an opportunity. This is on a different farm, but we're looking at some of the biosuppressive properties of some of these cover crops, oilseed radish on the left and oriental mustard on the right. Both these were slurry seeded, and these were in a sugar beet rotation. So we were looking at suppressing sugar beet cyst nematode with the radish and some of the soil-borne fungal diseases on the right with our oriental mustard. But we're quite pleased with the results. This is a seed bed with the slurry seeding, and it's horrifying, I guess is the only way to describe it if you're not used to it. But the seed-laden slurry is delivered together in this fractioned and loosened soil. It infiltrates quickly, and the liquid manure basically carries that cover crop seed down in, and it just finds cracks and fissures, what I call protected microsites, and it avoids the wide range of fluctuations in temperature and moisture that we see so often that cause failures with cover crops and some things, if we don't do tillage. So it's a little different approach, but we see seed emerging from variable depths, some as much as 3 or 4 inches down. But we're not sealing the surface. We're not tilling it. We're not covering it. So the seed has access to the surface, even though the roots may establish 3 or 4 inches deep. So it's a very interesting process, and I've really had some great cover crops doing this. This is Blight Farms, the cooperator that I showed you here a few minutes ago, Kalamazoo, loam soil, corn, soys, beef, and hogs, so mixed operation, farming about 3,000 acres at that point. This was seeded behind wheat, August 3rd through 6th, and we seeded oilseed radish, annual ryegrass, oats, and cereal rye in varying combinations. And I think I give you a sense of what we've got here. This is biomass in tons per acre. We had a late fall here and great weather, good moisture. We had phenomenal cover crops. A little bit too much, I think, heading into this. But I think basically if you look at here, we've got our different treatments. We drilled the airway plus oilseed radish, airway over the top. So we had a few drilled operations. We had a slurry seeding of rye and oilseed radish, oats and oilseed radish. We drilled with no manure, slurry seeded, and then we had drilled with manure. So quite a few different combinations across a 40-acre field, so we had some pretty good acreage to look at here. But I'll point out a few things. One is that oilseed radish in particular loves manure. And if you look at these two side-by-side comparisons, both were drilled, one with manure, one without. You can see here that the green is the oilseed radish root, the orange is the top growth foliage, yellow is annual ryegrass here. It was overwhelmed in some cases by the radish. Here's our oat foliage, the light green, and then cereal rye. You're not seeing very much of that. It was pretty much in every case oats is overwhelmed by the radish. But so you can see what we have here. It loves the manure. Oilseed radish is a great scavenger. We saw it easily pick up 125, 150 pounds of nitrogen. And you can see here, here, and here, these places where it was in contact with manure. Where we had drilled, it actually tended with no manure, Here it tended to favor the oats, but the oats in contact with oilseed radish were somewhat shaded out. Here you don't even see some of these other crops, the annual ryegrass and the rye and some of these things. At the top you barely see them because oilseed radish was so vigorous that the others were just could not compete. Here we had no manure. The oats did well, and oilseed radish mix is great even for grazing. But I think we still need to refine the rates and some of those things of radish and that when we're combining with manure, because manure does change things, particularly with oilseed radish. Oilseed radish with manure can overwhelm other cover crops, and we saw that here, even though we certainly had great cover. Now, many of our growers really like cereal rye, particularly if they're coming in later in the season. When we get into September, our options for cover crops begin to diminish. This is Doug Bloom in southern Michigan with a dairy farm. He frequently uses cereal rye. He likes it for a cover on this coarse textured soil to prevent wind erosion. But what he particularly likes as well is the opportunity to let that grow in the spring and then chop it and harvest it for feed. So we looked at a number of different ways of getting the seed out there because we know that there is a real crush for labor at this time of year. So slurry seeding is one option, but it's machine specific. So we really are looking for opportunities to get cover crops and manure together, and that can be any number of different ways. So we broadcasted one over the top of a very light disking, a number of different things. We drilled it, but each case we did a comparison with running slurry directly over the top of that. So in some cases we didn't have manure, but most cases, regardless of how we got the seed out there, we wanted to get it in contact with manure and get those nutrients available. So this is middle of September, 6 weeks later, and in all cases we had great cover crops. Normal rains, and things were working fairly well. Coarse textured soil, slurry seeding is not the best option in some of these coarse textured soil because they have a tendency to backfill before the slurry is in place. But this is Baker Lads Dairy, one of our other cooperators. We slurry seeded this field, a few different treatments, but he really enjoys this option of harvesting the crop in the spring depending on what his feed situation is, and it works very well for him. So we're seeing a range of options for folks, and I think sometimes it takes a little bit of effort to find out what the best option is for your farming system, but we see a lot of options out there. Give you a sense of what we saw there in some of our measurements. Again, this was at Bloom's Dairy. We went in fairly late in 2011. Corn silage came off a little later, so it was September 22nd. That cuts down our window a little bit. We typically expect some of our first frosts about October 10th, so the cover crops have to get up and jump, and that's one of the advantages of rye. But here we've got our oilseed radish drilled rye with airway manure over the top, and you can see there we got really a great stand of rye foliage. I think the drilling actually benefited in these conditions. Better seed soil contact. You can see here in each case where we had manure, we got a kind of a kick of the rye, but when we're broadcasting and drilling the oilseed radish, I think the radish got off to a quicker start, and then when we came in even later in the season with the October manure, it really kicked that. But you can see that the radish later in the season really is not producing a lot of root growth. We're getting fairly good top growth, but we're just not getting the root growth, and in many ways that's something that's quite desirable for us. So, again, manure changes things, and I think you need to have a little bit of an attitude of experimentation in order to get a sense of that on your farm and in your farming system and with your rotations. So this is another cooperator, Henry Miller Farm in Mendon. He uses a planter to plant oilseed radish in rows and then Austrian winter pea between the rows. And he's a seed corn grower, so he's going to be planting his seed corn directly over the oilseed radish in the row. He cuts down his seeding rate to about 2 pounds per acre this way. And then he looks for the Austrian winter pea to do it. We're using this vertical tillage operation to incorporate the applied manure, the surface applied swine manure that we'd add on some of these treatments. So, you know, most of our growers are a little bit in a sense wondering what these tillage tools actually do, but here we were interested in trying to reduce the volatilization losses of nitrogen related to the manure broadcast application. So I got some slow motion footage of this. It gives a better sense of what's happening across the field in some areas. A lot of our guys really like this for a residue management tool, more so probably with high yielding corn. But this is the cover crop that resulted. So even though we went directly over the top of a seeded cover crop with the vertical tillage tool, we didn't see much depression, or at least we still got a great cover crop. And we're still collecting information from this. We've got some of our nitrogen pickup information and yield, but we're still sort of sorting that out. This is part of a CIJ project that's just beginning, and we're looking at that data, so we'll have some more information on that later. But a lot other growers that are growing corn looking for opportunities for ryegrass. This is another slow motion video of some of these we call vertical tillage tools. This is behind the front gang, and then this is behind the second gang. But if we go in and broadcast our rye, we can cover a lot of ground with a broadcast application at 30 feet wide and 8 or 9 miles an hour with a broadcast seeder. And then if the folks are doing these operations in the fall in order to begin managing residue, it's a great opportunity to establish a cover crop. And you can see here, I think it reduces some of the risk of just surface broadcasting alone. So again, I think we have different windows. We benefit, I think, from having wheat. Many folks don't, but I think there are opportunities to get things out. So I think, you know, in looking at this, you know, sort of the farming system aspect, you know, I think we really need to keep that in mind. I think quite often we think we think we're farming it as a system because we sort of follow a regular sequence, but we really need to train ourselves a little bit more to think in terms of a system. What does one part of the system have, or how is it influencing other parts that are maybe not be closely related in time or you know, certainly throughout the year? Manure and cover crops are great companions. That's all I can say. Oilseed radish, I found it's a great crop for scavenging manure nutrients. However, I didn't talk about it today here, but it's really not so good in our experience with releasing nitrogen in synchrony with the needs of the following corn crop, at least in the northern states. I think it releases it too early, and various pathways cause it to disappear. But that's another topic, I guess. But oilseed radish can overwhelm other cover crops in a manure mix, so think about the rates, plant density, and I think bottom line is I think you can reclaim soil health with low-intensity tillage, livestock, manure, and cover crops. And if you have questions, so you can contact me at the email address below, and I'd be happy to further discuss it or write a response, whatever it may be. Again, that's all I've got today, so thanks for joining us.
Thank you, Tim. As we're switching over to Kent's presentation, a couple questions you could probably answer fairly quickly, Tim. There's a few questions around the slurry, how it was stored, was it open, that it was mixed with rain, any type of analysis related to it that you might have.
Well, I didn't put that up. With the dairy, it is fairly typical for us. The analysis was probably 25 pounds of nitrogen. P&K would be probably 12 or 15 per 1,000 gallons, and potassium. The swine slurry was about 50 pounds of actual nitrogen per 1,000. So it was, you know, it was fairly nutrient dense. And I have some. We did do EC measurements on that. I have that, but I don't have it right at my fingertips. But certainly on some of the applications with you know, these things we need to be attentive to. Some of the work that my colleagues at Purdue did, looking at some of the details of slurry seeding and effects on some of these cover crops, their sense was perhaps ammonia toxicity might be a little bit more of a concern in some cases than salinity itself. So I think those are good questions, and I think they're probably deserve a little more detailed answers. But for us, the manure was pretty typical of what we would apply here.
Okay, and one other one that's semi-related. Did you see an increase in earthworms as they were changing over with the oilseed radish plots? Did you see any changes in that? Was that measured?
So far, we did not measure that in these trials. We're just starting this other trial that the last video was 3 locations. One was the Blight Farm again, and earthworm populations are a part of that. So the earlier CIG was really sort of a proof of concept for slurry seeding. The second one is more related to opportunities to actually improve soil health with low disturbance tillage, manure and cover crops, and some other opportunities along the way.
Okay. Thanks, Tim, and we'll come back to Tim at the end with Kent after Kent's done talking. So, Kent, go ahead and do your presentation.
Well, thank you, Luther, and good afternoon to everyone. Glad you could join us today. It's always exciting to be talking about cover crops. There's so much innovation going on these days with the cover crops and cropping systems, and it was exciting to hear some of the work Tim's doing there in Michigan with manure slurry. I find that excellent that there's other tools out there we can consider and use. I'm going to take a little different stab at combining livestock manure and cover crops today. Before we get into that, I want to back up and just kind of give some context to where I'm going here. And that cover crops, I look at them as a soil health building tool. And when we're talking soil health, or when I'm speaking about soil health today, I'm focusing on soil function and what the soil is going to be able to do and do for us. What we're finding with the work we're doing here in Minnesota is that we're getting our best results when cover crops are used in concert with a number of other management techniques, and that includes diversifying the crop rotation and making sure through that crop rotation we're providing living roots most of the year, the living roots providing the habitat for the soil microbes so they can be working for us. To minimize our tillage, as Tim was saying, possibly with an emphasis on no-till in many situations. And then the integration of livestock. And like I said, I'm going to talk a little bit different angle about integrating livestock. I look at cover crops as a bridge between our livestock systems and our cropping systems. And I think this creates a huge window of opportunity for building soil health. Just a few comments on ruminant livestock and the importance they may play in soil health and how they tie into cover crops. Essentially, our ruminants are a walking vat of microbes, and as one soil scientist explained to me at one point in time, we cannot replace in a jug or bag what comes out the back end of a ruminant. And I think that just bodes real well for soil science. There are other things we gain from livestock, including hoof action, saliva, shed hair, and if they have young at sight, even milk foam. And there's evidence to suggest that those all contribute to the soil micropopulation and to ultimately building soil health. It's not something we hear about a lot. They're kind of more of the micro side of things here, but in a grassland system, as we look across the globe, whether it's the Great Plains in North America or the Serengeti in Africa, livestock or ruminant animals were tied to that so closely, and I think they contributed much more to the system than we fully realize right now and are continuing to learn about. So as far as integrating cover crops, I'd like to talk about a few options where we've seen opportunities for producers. And as Tim talked about, after a small grain harvest, excellent opportunity, or even field pea, using full season cover crops. That tends to be something people with livestock are more interested in than just row crop farmers. Prevent plant acres. We had a lot of prevent plant acres in Minnesota last year, and there was some confusion and some possibly some conflict and concern with crop insurance. We're not going to get into that today, but it was certainly an opportunity to incorporate cover crops, and there could have been some huge benefits for soil health and future productivity of those acres, and they could have been utilized there. Another opportunity is with silage corn as we move farther north into the Dakotas, Minnesota, even Michigan, Wisconsin. We run into a much shorter growing season, and our window for using cover crops gets very small. However, we've had some producers that have successfully used cover crops with silage corn, and then also with grain corn and soybeans. This one gets to be a little trickier because of our shorter growing season. At the same time, as difficult as sometimes this can be because of that, this is also the one that there seems to be the most interest in. So I just toss that out as just to be advised that it's possible, but there's some complications with that because of our short growing season. I'd like to move into some examples and some applications of cover crops with producers that I've been involved with and myself have attempted to use, and we've had some successes with. This example here almost falls in the category of like double cropping here. This field was planted to oats and field peas in the spring, and we didn't have much of a spring last year, but he got it in. And at the same time when he planted that, he planted a mix of brassicas with that, some clovers, and then we were hoping for some resprouting of the oats. Well, he took the oats and peas off as a hay crop, and he does have a beef herd, so this was allowed to regrow. And mostly the brassicas regrow. We didn't see near the response from the clovers and the oats resprouting that we had hoped for, but he did get a really nice forage crop out here, and this was extremely valuable to this producer because we went about 6 weeks in the area where this picture was taken without rain, and so he was hurt for pasture come September. And this was a real lifesaver for him in a year where hay prices were high and hay was in short supply. And he was very happy with this. These cows still had calves outside, and he continues to this day to be pleased with the weight gains his calves showed as a result of this. Another field where we did some work with kind of a double cropping system, if you will. This field was in alfalfa. It was a thinning stand. It was an older stand. There were some thistle issues associated with it. And so this producer opted to take the first crop alfalfa off as hay, and then he sprayed it and worked it up and planted this complex cover crop mix in it. And he allowed this to grow into November. And this picture was taken in October, mid to late October. He did not bring cattle onto this until the first Wednesday in November, and I called him on December 10th just to see how things were going with that and if the cattle were still out there, and he said absolutely. He hadn't removed them yet, although we had 12 inches of snow on this site the week before. The cattle were still going out there, not as enthusiastically as they were when there wasn't any snow, but they were still going out there, and he was still gaining some benefit from that. And he was quite enthusiastic about this. Again, a situation where hay supplies were tight and to buy hay was quite expensive. He was quite happy with this. Here's an example of a full season cover crop mix we did on our farm last year. This is a site that had cattle wintered on it the winter before, and we wanted to take advantage of those nutrients. This full season blend was allowed to grow until we had hard freezes in October, and then the livestock were allowed to graze in it. Just as kind of a reference, here's what was in that mix. Sorghum Sudan cross, pearl millet and open pollinated corn, sunflower, red clover, cowpea, purple top turnip, the Winfred hybrid turnip, and a forage radish. So that can kind of give you an idea of what that blend looks like. I'd like to touch a bit on opportunities or options for seeding cover crops in corn and or soybeans. We have producers doing this a number of different ways. One is seeding the cover crop through either broadcast, or we've had one gentleman in Minnesota who's designed his own drop tube seeder, and they're seeding this at the V6 stage in corn. The drop tube seeder, the producer had an old toolbar around, and he got a hold of some old seed boxes and mounted those with drop tubes coming down based on the row spacing of his corn, and he had a hydraulic orbit seeder or orbit motor on the shaft that moved the seed into the tubes and dropped it in, and actually had some pretty good success with that. That was just a kind of a home brewed deal. Other seedings opportunities are aerial or modified white boy seedings in late summer. Typically these are happening 2 to 3 weeks before silage harvest. In soybeans, these are taking place when we're showing about 25 to 50% yellowing of the plant. On grain corn, we're trying to get that in when the corn plant has dried to about the ear. Seems to be about the appropriate time to do that. One of the things we're working with producers on, because many of these producers are only doing this on, say, 40 to upwards of 100 acres at a time, it's a little difficult to get custom applicators, whether that's an aerial applicator or a high boy custom service, to make the switch in their equipment, is encouraging producers to pool acres. So instead of 50 or 100 or 80 acres, now they might have 400 to possibly 1,000 acres pooled, and they can approach a custom service provider, let them know what they want to do, let them know the type of seed they're going to use and when they're hoping to get this in, and that custom service applicator can plan accordingly, and there's enough incentive there with the number of producers that it becomes cost effective not only for the applicator but for the producer to make that swap out of equipment so they're ready to go. So we're finding some success with that. But the bottom line here is we're working on adding diversity, and we can use clovers, a variety of brassicas, cereal rye, and or annual ryegrass in these systems. Here's just a shot of some cereal rye and a couple brassicas that was aerially seeded into some standing corn. This picture was taken about 2 weeks after that application occurred. One of the benefits we find as far as integrating livestock and getting manure on the landscape is by using cover crops in these systems is we have a number of producers in our area that like to turn the cattle out after corn harvest and do some gleaning of what's out there. It's a great way to utilize that acreage, help keep feed costs down for cattle, and get some manure out there. One of the disadvantages of this system is it's fairly coarse feed. It's fairly low in nutrients, particularly protein, and the most common way to address this, producers have put out a nice second crop alfalfa bale or two for the animals to go back and help balance their rumen. But by adding a variety of some of these cover crops that we talked about here earlier, now we're providing some of that protein need for the livestock. And so it's a kind of an inexpensive way to get better utilization of gleaning those crop fields, and it's one opportunity that's available. We talked a little bit earlier about designing complex cover crop blends. These are usually 8 or more species in the blend. The biggest thing I encourage producers to think about when they're doing this is first thinking about what resource issues do you want to address. There's really no one-size-fits-all. There's no recipe for doing this, but it's looking at a field-by-field situation on what are the resource issues that need to be addressed there. Some of these resource issues could be building soil organic matter, heading towards improving soil aggregate structure, which ultimately can improve our water cycle and enhance nutrient cycling. Possibly integrated pest management. We're seeing some producers using complex cover crops and integration with livestock that have been able to reduce their herbicide use by over 75%. Enhancing pollinators. We've probably all seen the headlines about the problems that beekeepers are having and bee colonies are having with colony collapse disorder. This is a way to come alongside those beekeepers and provide some opportunity there, and I believe there's cost share assistance through EQIP to do this that may fit into a management plan for a particular field. Providing soil armor and cover, not only to reduce erosion, but to minimize evapotranspiration and conserve the water that is out there. Adjusting carbon-nitrogen ratio is huge. We have some producers that really struggle with this as far as decomposition of crop residue from the year before, and cover crop blends can be adjusted to help deal with that. I do want to touch on really the power of diversity for a moment. In these complex cover crop blends, this photo was taken by a friend of mine who attended the Grass-Fed Exchange workshop in Bismarck, North Dakota last year. This picture was taken at Brown's Ranch. It's run by Gabe and Paul Brown. Maybe you've seen their names in the ag press. They're kind of innovators and real leaders from the farmer aspect on encouraging these types of management practices. This picture was taken on August 20th of 2013, and it's a picture of part of the cow herd in a complex cover crop blend of about 30 species. This field was planted, on June 26th, and since that field was planted, it had only received a half-inch of rain. And the day this picture was taken, it was 1 in the afternoon, and it was about 100 degrees Fahrenheit out there. This is a huge forage resource for a livestock producer, and soil health can be built at the same time. Typically in these fields, the livestock are only taking about 30 to 40% of the forage. They're being strip grazed through here, so they're in there at very high densities, and we want to see some trampling effect there to provide some soil armor and help feed those soil microbes, minimize erosion, and help reduce evaporation rates. You know, if we think of what do most of our pastures look like near the end of August on a 100-degree day, and it's only rained a half-inch in the last, 7 weeks or so, 6 or 7 weeks, they don't look so good. And this becomes a wonderful resource as part of a bigger cropping system, as part of a bigger cropping rotation to integrate livestock and make sure they're fed. And really we're looking at providing diversity in these complex cover crop mixes in the soils. That diversity in root systems is providing a habitat for a wide variety of soil microbes, and that's going to help move us towards soil health. So with that, here's my contact information, and if you do have further questions or want to talk more about this, feel free to contact me.
Thank you, Kent. What I'll do now is we'll start addressing some of the questions, and we'll take a look at some of these and walk through them. And we have about 10 minutes left in the broadcast. This question is asking about quality parameters taken on these, and are you typically seeing only cow-calf, or do you see 500 to 600 weight stockers?
Both. We're seeing several classes of livestock being used. There was some work done with complex cover crop mixes out in North Dakota here a few years back where wean calves, 500 to 600 pound stockers, were put on a complex cover crop mix later in the fall. So a hard frost had terminated a lot of the species in the mix, but because it was a diverse mix, there was still some forage out there, and they were seeing over 3 pounds a day average daily gain on those wean calves. So that's pretty respectable in anybody's book from a beef perspective.
Okay, this one might be more towards Tim. How do you mix the cover crop seed in the manure slurry?
Well, I don't overcomplicate it. We use top-loaded tanks. So basically, when the manure is being pumped into the tank, I usually have sort of a calibrated pail, or at least I know, I'll make a mark if I need a certain number of pounds, and I've got a light aluminum ladder there, and while the tank's filling, I throw the ladder up alongside the tank, and I dump it in the tank. And then we do some agitation on that. We've got a PTO pump, and we don't need the full flow through there, so we always have to back that off a little bit in order to run it through injectors. So what doesn't come out through the injectors recirculates, and that's how we get agitation in the tank. So basically, it's a simple process.
And then, Tim, here's another one in response to the research you were doing. They're asking about, excuse me, the dates of when the rye was chopped, and did that delay corn planting?
I'd have to go back and look, but basically both these farmers had some experience with rye, so they're looking at getting there and getting it chopped. So they're looking for a window, but I can't tell the exact dates, but they have some experience managing it. I know it's a challenge sometimes with rye because it can get away with you, but get away from you sometimes. But they're pretty competent in that area.
Okay, and Tim, do you know if they noticed any yield reduction in the corn or anything? And again, it based on when it was planted and the timing. I know you were talking about a window they were trying to hit. I don't know.
I think well, the one blooms, they're on a coarse textured soil, so they're on irrigated ground, so he's not quite so concerned. Baker lads, which I showed at the end, actually taking it off, they're on a blunt loam soil, and they don't report to me any or at least they haven't mentioned anything about yield reductions regarding cereal rye. But they're in the no-till situation, so certainly that's possible under certain circumstances in a dry year. But they don't seem too concerned about it.
Okay, and this one I believe might be for either one of you to address, or both of you. It's asking about the variety of the cover that was planted into standing corn at V6 stage.
The variety of cover crops, usually we're only looking in those situations 1 to 3, maybe 4 cover crop species in the mix, and it's at very light rates, 3 to 5 pounds per acre. So there might be, like for example, crimson clover, a couple different brassicas, possibly annual rye. The cereal rye is usually seeded later. But yeah, there's usually only about 2 or 3 species in the mix.
Okay. And Kent, it again goes on to ask about competition with the cover crop and between the cover crop and for the corn, corn crop.
So far, we're just not really seeing a whole lot of competition. You know, everything seems to be pretty nominal as far as potential yield losses. So, just hasn't been a big issue.
Okay. Do you have any cost estimates on the mixed cover crops?
The complex cover crop mixes, depending on what you're putting in your blend, they're running anywhere from just the seed mix is running from about $28 to $55 an acre.
Okay. This one I believe you addressed, but maybe you can say it again or come back to it a little bit. They're talking about that multi-species mix, and when you have multiple seed varieties and densities, how are you doing the seeding? Through a drill, through a planter? I know you've talked about some of this at both drill and broadcast, but if either one of you want to talk about it a little more.
I can address the complex cover crop mixes. Most producers are using a no-till drill of some sort. We're finding that some drills work better than others. You might need to experiment a little bit depending on your drill. We found with some drills that it's been valuable to split out the small seed, for example, the pearl millet, brassicas, and the clovers, and put them in the small seed box. Seeding things like the sorghum or sorghum Sudan separately. That seed tends to be like little bird shot, wants to flow real quickly through there, and then combining the rest of the seed in another planter box on the same drill, if that's an option. Other folks are combining everything together, and they're only filling the box, a seed box, about a third full. That's to minimize sifting certain sizes of seeds through there. I realize it's not the most convenient, but they're finding that just filling it a third full versus filling the box full all the way minimizes that, and it works well. We have other people who are doing broadcasting, and they're having quite a bit of success with that. It seems like a coarser seed bed preparation versus a finer seed bed preparation if you're going to broadcast it tends to work a little better on, and then just a light drag afterwards to incorporate it. So I'll let Tim talk about his experience.
I think ours is the same. I think, if you've got something like turnip seeds, certainly if you've got a legume box on the drill, it's probably a little easier to deal with that. But I think for the most part, in some of the mixes, I think our guys are just, trying to, for instance, if they've got 3 seeds in the mix, they'll look at standard seeding rates and take a third of each, and then mix those together, set the drill for the largest seed, and not sweat the small stuff. Just seed it and see. I mean, it seems to be working pretty well. Try not to make it too complex.
Okay. This question again is talking about the seed and using the mix of cover crops of 8, 10, or even more species, rather than maybe around just maybe 3 based on functional groups, grouping them as legumes or grasses or brassicas. And they're looking at, are multiple legumes, for example, better than choosing just the best legume for a less complex mix? So they're asking, going the other way with the number of varieties, keeping the number of species smaller, but looking at functional grouping. Do either of you want to address that?
I'll make a couple comments. What we're finding is these complex mixes, there's some synergy going on between them that under stressful situations, the mix as a whole seems to be more of a measure of success than lesser species in the mix. So my bias has been towards, from what we've seen, has been towards the more complex mixes and even using a number of different legumes in that mix. Again, going back to your resource needs. There's a test out there, the Haney soil test, that is really showing some promise in helping people design the amount of legume in the mix. It doesn't tell you exact species types, but it can give you some recommendations of percentages of legumes in the mix versus percentages of grasses based on where your soils are, your soil biology is at that particular field for that particular year. And that can be a powerful tool in helping design these complex cover crop mixes.
Switch a little bit of, go ahead.
This is Tim. I just wanted to say I agree with that. I think it's certainly hard to argue with greater diversity, but I think we, I don't think we know, at least from an academic standpoint, a lot about that at this point. But I really think the key thing is, don't worry if you can't get a complex mix. Get 1 or 2 crops. Certainly there are practical limitations depending on what rotations you're dealing with and those types of things. But get 1. Get at least 1.
Yeah, get started, absolutely.
To switch a little bit of the discussion on the questions, we have time for maybe one or 2 more. And there's a couple questions here around herbicide program and what type of herbicides were used with the planting of the cover crops in the V6 corn specifically. So do either of you want to address the type of herbicide programs that were used in your programs to look at the cover crops?
The field that I showed a slide for, that was someone else's field, and they didn't give me the herbicide information, so I don't have an answer for that particular application. It's definitely a concern. You do want to think about carryover issues and what you might be planting for a cover crop, so that is something to think about, now, even if you might not be seeding it till later. The complex cover crop blends typically, if there is going to be herbicide application prior to the incorporation of a cover crop, it's usually a glyphosate burn down.
Okay, well that'll pretty much bring us to the end of today's webinar. I want to thank both our speakers, Tim and Kent, for taking the time today to talk with us about this very important topic. And again, thank our sponsors who are listed on our screen for their support and being able to bring you this series on cover crops at no charge to you as a participant. If you are interested in our next 2, which will be March 20th is our next one on cover crop seed selection and planting, followed by March 27th on cover crop management and termination. Please go to our website, www.agronomy.org, and you can find out more information and you can register for those. Thank you everyone for joining us today, and that'll conclude our webinar. Thank you.